Testing. Okay. Good afternoon, everyone. Thanks for joining us this afternoon. We know that we are standing between you and the party, so we truly appreciate your time here. I'm going to try to make it as entertaining as possible. This is a 300-level presentation, as you all know. It's not very common that we have 300-level presentation on the architecture track. Architecture track usually is more theoretical in strategy and things like that. This particular session, we're going to try to have some demos, which is also not usual on the architecture track, just to demonstrate some of the things that were said on the previous 2 days on this particular track. My name is Yuri Diogenes. I'm a senior technical writer at Microsoft US. The team that I work for writes solutions for private cloud and cloud infrastructure. Prior to joining this team, I was on CSS security, working with TMG, and co-work with Karin. And Karin?
Hello, good afternoon, everyone. Yes, I'm Karin Gali. I'm support escalation engineer in the networking team here in Madrid, in Spain. I've been working here for the last year, and previously, as Yuri said, I was working also in support in ISA TMG.
So we do have a pretty strong background in security for all these years working on CSS security. And on this particular session, what we're going to try to do is to bring some of the theoretical concepts together with security and networking. We're going to really work on those two pillars for this presentation. We're going to go through a little discussion about the evolution of the data center and starting the architecture and network infrastructure. And then Karin will take over. Karin currently is working on the networking team, so she's going to go in more details about some of the capabilities. We're not going to go dive into more details of R2. We do have a session specifically for networking on R2. We're going to mention some of the features and some of the chains based on what we're going to present. But for R2, we're going to reference another session that you can go just for news on R2. Then we go to planning network with security in mind. Again, bringing this background of security that we have, and this is something that we try to do on our team as well. Another writer on my team is Tom Schinder. You probably know him from the isoserver.org, being Microsoft for many years as well. We've been writing books together for the past 5 years, TMG, Windows Server 2012. And on our team, we try to embed security in all our documents. And moving forward, we're going to touch a little bit on R2, just to compare with some of the things that we saw through the presentation, okay? So as far as the evolution of data center, I'm pretty sure that you guys probably saw many presentations this week so far about cloud and everything else. But how really it came to this point and why is a big advantage? Well, we really start with a dedicated server, no virtualization. And one of the main advantages of that was the hardware isolation. So from the security perspective, how you have a hardening for one particular server because there was one role only. If you have a file server, you have hardening for that server. And physically, they were isolated from each other. So if one server go down, probably only one service will also fail because it was one by one. It was not very scalable and very hard to manage. Then we moved to a more virtualized world where we have logical capabilities and logical isolation. We still need to maintain security on the virtualization perspective, but we are able to consolidate servers. This is not cloud. Something that we've been trying to say a lot of time is virtualization is not cloud. It's only part of cloud, but it's not really cloud. If you have a service virtualization, you probably do not have a whole cloud story implemented. Okay? So with this evolution, we were able to scale out easily, and we also have new threats because as we change our hardware and our software, we have a new threat landscape from the virtualization standpoint. And one of the most common questions is, what if my hypervisor is compromised? Well, probably at that point, all other VMs might be compromised as well. So the threat landscape changed, the hardening changed, but it is an evolution the way we used to do things on the data center. Now, moving forward, and that's why we call modern data center, is because now we leverage the 5 essential characteristics of cloud computing defined by NIST. which probably you heard many times those characteristics. But in summary, we have shared computing, storage, network resources. So now, in the past, you isolate things in the piece of hardware. Now you can have competitors running on the same pool of resources. So there is a different way to think now. We need isolation between tenants. And even if you have cloud on your own infrastructure, which we also call private cloud, you still have to be concerned about how to isolate those tenants. Because in a cloud, in a private cloud, who are the tenants? Usually the departments, right? The divisions within the organization. We have this pretty clear at Microsoft, for example. The Exchange team has their own separation, isolation. The Windows team has many isolations. So one team will not share information with each other for some projects, but they might share in different projects. So we have isolation from the application level to the logical level on the hypervisor. So this new way to leverage IT resources for the data center is pretty much leveraging cloud computer resource. Okay, so even if you are not moving to the cloud right away, we always ask you to think on the data center as you were a hoster of those services. Okay, because that way you are leveraging some key characteristics that if you want to move forward and maybe go to a hybrid environment, you already have a private cloud running, or you have some of the characteristics of cloud computing running on your internal data center. Now, what we will really cover on this presentation, we will cover the core of networking and security. And in order to do that, we're going to leverage one model, one reference model that our team put together. It's called Private Cloud Reference Model. And this is the reference model right there. You can look that we make some divisions. And the reason why I'm putting a highlight on the infrastructure in particular is because that is the area where we're going to cover, in particular network. So if you think about cloud, a private cloud, there are many modules that you can implement. It was funny because I was at TechEd in New Orleans and I received a question. I was in a booth for the Building Clouds booth on that day, and I received a question that was, Yuri, can you explain me a little bit more about System Center and how can I build a cloud with System Center? I'm not a System Center guy, and I was very honest with that. I said, well, I'm not a System Center resource, but I can talk to you about cloud infrastructure, which is something that you must have even before you have the management layer on top of that. And the guy was like, well, I don't understand. Why do I need a cloud infrastructure? Well, you're always going to need that before you have the management. Okay, so when we are preaching you the networking capabilities that come with the platform and why you should implement those capabilities with security in mind is because we want you to build a secure foundation. It doesn't really matter if you have an excellent management infrastructure on top of that if your foundation is pretty weak. Okay, at some point you're going to have breaches, at some point you have some vulnerabilities because you didn't plan very well and you didn't embed security on the foundation of your cloud infrastructure. Okay. So moving to the architecture network infrastructure, I think the pretty clear question is, does your network look something like this? Not from the cabling perspective, probably not, but from the evolving perspective. I mean, your network at some point was IPS, XPS, then you put NetBEUI, then you start TCP/IP, and then you start to integrate things, and you have a legacy application work with NetBEUI just because you need to. Then you still have a Win server running on your network just because there are another application that needs to, right? But have you ever stopped to rethink the whole networking and how could you do that to really optimize things? So that's the idea of architecting a network infrastructure, which is something that Karin is going to talk about now.
Thank you. Okay, so if we go to architecting a network infrastructure, we really need to think about many different things because in the end, our networking will be the base where all our services will be laying on. So we really need to think about many different things, right? We need to think about the scenario we're going to go to. Are we going to enterprise approach? Are we going to cloud, private, public? We need to think about the services that we want to offer. Are we going to web services, file services, remote access. So all of them may need different hardware, software, right? So we really need to make a good capacity planning, make a good thing, really rethink, as Yuri said, all of our networking to start with a very good basis, to start with a very good plan, and just to avoid many later changes. Because no matter really if you're going to private, public, whatever, if you're using virtualization, all of your services will be on top of that, and we really need to make sure that the networking constantly working fine. So let's see some of the new features that Windows 2012 had to offer us. What about enterprise network? I'm going to move here. So if we think about if we have our main office, we may have, for example, file access. We may have file servers. So one of the improvements we have here is the new version of SMB, which is SMB3. SMB3 really is giving us a lot of improvement, quite a lot of new features, multi-channel, encryption, Hyper-V over SMB. So we really have quite a lot of more, and it's going to give us a lot of better performance and failover capabilities also. What if we talk about having DHCP, DNS in our enterprise? We already have IPAM as a new feature we have in 2012. It's a complete new feature. And with IPAM, what we have is centralized management for both DHCP and DNS. From here, we can monitor, audit, manage DHCP leases, our DNS infrastructure. So it's really very good and make it the IT administration much easier. Okay. What if we have some branch offices? We still have branch cache with some improvements. Branch cache, for those of you who doesn't know basically what we are going to do, is that the client on the branch office taking data from our main office, from our cloud, is going to be cached here. We can cache it depending on the scenario we go. We can just cache it on the server, on the clients, and this will minimize the access through the one leg, so really enhancing the performance here. What if we have external clients? We have new direct access improved from what we had in 28. We have improved management. We have improved performance, for example, by using IP HTTPS with null encryption. This will give us much faster performance. We have the users, for example, being able to choose on their own which direct access site they want to access. If they want to access many different sites that we have direct access, I can choose to go to Europe, to US, to a specific country, to whatever sites we have. And we still have traditional VPN. The good news here is that we can have both roles, direct access and VPN, on the same server. So this is very good news also. And what happens if we go to a cloud approach? What new things we have here in 2012? If I tell you the truth, I'm just showing just some of them, not all of them, but I just want to give you a quick glimpse here. One of the things we have is data center bridging. Data center bridging will help us in just managing the bandwidth, basically the minimum bandwidth that we are going to apply to different applications, because they may need a very good manage of the bandwidth. We're going deeper later because we are going to talk about QoS. We also have NIC teaming providing failover for the network adapters, for the connection, and bandwidth aggregation. We have our Hyper-V switch, which is now extensible. And this means that we have now a public API that vendors can use to create new extensions, for example, firewall extensions that we can just integrate in the Hyper-V switch, making it even more powerful. We have network virtualization. How many of you guys using network virtualization here? Not many of you? So network virtualization, basically, what it will give us is just to decouple the physical network into virtual networks. We can just bring our customers, our clients, our users' address space into a virtual world. We can have isolation. We can isolate one customer, one department from the other. And on the network stack, we have, for example, TCP Datacenter TCP, which is using ECN, explicit congestion notification, just to make sure that we discover any congestion that could be in the network and we can act on this. And by act, I mean, if we have a congestion on the network and everything is going slow and really we are having packets that get lost, we are going to slow down. We are going to say, OK, for all the outbound traffic, I'm going to slow down a little bit. So with this, I'm going to give some time for the congestion to really get fixed, and we can continue at the same rate. So these are just some of the examples that we have of the new features that we have in 2012. So I want to talk about the first one, which is load balancing and failover, also known as NIC teaming. How many of you is using NIC teaming already? Hardware NIC teaming or 2012 NIC teaming? Both? OK, so for you who already work with hardware NIC teaming, you may know that usually one of the requirements was to have in the same team network adapters, of course, of the same vendor, but many times also the same model. So this is really very restrictive. And the good news that we have here in 2012 is that we can have in a single team different adapters, different vendors, different models, no matter what that is going to work. We still have some limitations, some requirements, specific requirements that we're going to show later. But this is very good news, I think. What we are getting with NIC teaming, we are getting high availability and how we are going to do this. Because we have bandwidth aggregation, we can have as more adapters that we add, we are going to have more bandwidth. And we are going to have failover, because as soon as we have minimum 2 network adapters, if one fails, we still have the other working. So we make sure that our networking continues and no problems for our services. We are going to make them work without any problems. And the last one is Cloud Foundation. We have this feature designed to meet basically requirements for a cloud OS. And why we say this? Because basically, if we think about a cloud, we may have a lot of virtual machines that depends on our physical networks in the end. And if we don't have any fault tolerance here, we really can be in a very bad situation. If one fails, all of our network or virtual machines will fail, right? So let's see what are the benefits we have. We already explained. Let's see just a little images here. For bandwidth aggregation, we may have one single network adapter. What happens here is that we have our traffic just flowing, everything is fine. But what happens if we just start adding more network adapters? Our pipe will be better. We have more bandwidth, and more traffic can be handled at the same time, right? So this could be for bandwidth aggregation. And for failover, just imagine you have at least 2 network adapters. We have, again, our traffic flowing. But what happens if one of the network adapters fails? We still have our traffic flowing because we still have one network adapter live. And the user shouldn't really notice any change here, any failure here. And of course, everybody's happy. The users didn't notice. The IT department didn't really get a lot of calls saying, come on, this is not working. Perfect. So let's go through the configuration types we have for NIC teaming. We have mainly 2 different types. The first one is switch independent, which means that the switch which we connect the network adapters to is not going to be aware of any team in the bottom. So in this case, we can connect. It's not a requirement, but we can connect the different network adapters to different switches. In this case, this is a very good thing, I think, in the sense that it's going to give us also failover, because if we connect the network adapters to different switches, if one switch fails, then we still have the other working and the other network adapter working. If we are just connecting all to the same switch, if the switch fails, we still have a complete failure here, right? So here, at least you need to be aware that the switch won't be aware at all that we have a team here. So basically, we are going to use this for failover capabilities. And the second type we have is switch dependent. In this case, of course, we need to connect all the network adapters to the same switch. And we really need the switch be aware of this team, be part of this team. And how we are going to do this, we have two different ways to do this. We can have a static or manual configuration. So we really need to go to the switch and say, hey, these network adapters, these links that you're getting here are part of a single team. You need to consider them as a whole entity. Or we may use the LACP protocol, which will help us in doing this a little bit more dynamic. It will automatically discover the links that are part of a single team. We still may need some manual configuration. We still need to go to the switch and say, hey, I'm going to use LACP, but basically it will just give us a little bit of easier configuration here. But that, of course, is if the switch is capable of. So these are the two types we have. Let's see what are the distribution algorithms we have here. As we're talking that we may have load balancing for the traffic, we have two different algorithms. The first one, Hyper-V switch port. In this case, we are going to use the Hyper-V switch port number as the component to be used to really load the balancing and decide where we need to route this traffic. So if we just have several virtual machines which are connected to Hyper-V switch port number 1, all traffic, all outbound traffic will go this way. All traffic which is from VMs connected to the switch port number 2 will go this way, right? If we do a combination with what we see previously, the different types we have, for example, if we use a switch independent here for outbound, we are going to use the Hyper-V switch port. For inbound, we are going to use the other, we're still going to use the switch port also. If we are going to use switch dependent, in this case where the switch was aware and just making the load balancing, for inbound traffic, we are going just to use the load balancing algorithm that is the switch using. And for the second type of traffic distribution, we have address hashing. For this one, we are going to use source and destination MAC address, source and destination IP address, source and destination port as things, components that we're going to use in the balancing decision. So basically what we want to achieve here anyway is just to make sure that all traffic, the same streams go through the same, go through the same network adapter so we don't get any packets lost, dropped, or whatever. And this, for example, the same. If we think about the combination with switch independent, in this case, we are going to use the MAC address again, the IP address and port for inbound traffic. Basically, we are going to use the same, but as one single MAC address can be just mapped to a single IP address, usually what we are going to take is that all inbound traffic is arriving to a single network adapter. In the other hand, if we think about the combination with switch dependent, what we are going to use is here exactly the same for outbound traffic, but for inbound traffic, the switch we're going to use the load balancing algorithm that it has, and it starts load balancing through the network adapters. Okay, so let's go here. We have the requirements and limitations that we were talking about. What about if we talk about physical adapters? Because what we can have is snake teaming enabled in both physical network, virtual network, both of them. So let's see what are the requirements here. We can have one adapter, so we are going to separate the traffic, in this case, using the different VLANs. We can have at least 2 adapters to start having failover capabilities. So if one goes down, the other one is still working. And we can have up to 32 adapters. Again, I repeat, just to make sure we are on physical NICs, right? So we can have up to 32, which is pretty much quite a lot in a single team. Some other things that we need to have in mind. We are only talking about Ethernet adapters. We are not talking about Wi-Fi, Bluetooth, whatever other kind of adapters. We are always talking about Ethernet. We cannot really have teams of teams. If I already have a team, I cannot go, for example, to my virtual machine and create a new team here, okay? Because this, of course, can create just conflicts. Okay, so here, what about the limitations for a virtual machine? Of course, we can only connect them to use NICs connected to the external switch. This makes sense because the external switch will be the only one who is connecting to a physical network adapter, right? Internal, private are not doing that. So only connected to external switch. We can have, and you see here the difference, only as much as 2 adapters per team. Okay, we know larger teams can be created, but please have in mind that this is not supported. So this is really something that you need to have in mind. That doesn't mean that it doesn't work, but at least we are not going to support that. Okay.
So Karin is going to demonstrate that, but before, I just want to give a brief description of the scenario because one of the feedbacks that we keep hearing is that when you do a demo, make sure that you set the stage about what you're trying to accomplish, not only showing the feature, right? So within that context of private cloud, we're going to use that well-known organization called Contoso that needs to implement a solution in their private cloud that allow their tenants to access the VMs even if when one network card fails. So it's pretty much a very simple scenario. The goal here is to show some of the capabilities of the LVFO. This is the diagram of the hypervisor that we have: live migration network, cluster storage network, and managed network. We're going to implement this on the tenant network. So this is the network that we're going to use here. So, Karin.
Okay. Okay, so number 6, is this me? Okay, perfect. Okay, so let's go to the server first. Okay, here I'm connecting directly to my physical server where I just configure NIC teaming. Let's open this so you can see it here. Here is my NIC teaming interface. You can see that I have one NIC teaming here created. I'm using 2 different physical adapters, physical 1 and physical 2. We can see here, let's show you the properties of this team. And here we can see we have the options we have seen before, right? Switch independent, where the switch was not aware of a team underneath. We have static teaming and LACP, both being switch dependent. It depends if you are using complete manual configuration or getting help from the LACP protocol. We have the different load balancing modes here: hash port, address hash, and Hyper-V port. We also have the option to use and say that we are going to have a standby adapter. This means that we can have as much adapters working, but we can just leave one for just standby and say, okay, wait until something happens with the other adapter. If it fails, then you stand up and start working. For the moment, I just leave the configuration like this. I want to show you just that I have here my network adapters. So you can see it, physical 1 and physical 2. Here is my team. You can see that it creates a new adapter here. In fact, this one is the one that I have publishing in DNS. So right now I'm connecting directly my remote desktop session to this NIC teaming. And here you can see that we have also a virtual adapter that I created because I also have another server. So I can show you both how it works with virtual and physical. And here I have another server. I just created in my Hyper-V switch a new switch which is connected to my external team. Yes, because I use both physical adapters to create my team, so I'm showing and exposing my team to the virtual manager. And here we can see I'm using this Microsoft Network Adapter Multiplexer driver, which is in the end, the adapter for the NIC team. And you can see that we have the other 3, which were the physical adapters. One of them is disabled. So I'm going to use these. So you can see that I'm using my team to create this virtual adapter for the virtual machine. And here, finally, we can see just the configuration from my virtual machine so you can see that it is using my physical team that I created, okay? So here I just created a couple of performance counters which are showing bytes sent and received of both physical servers and from my NIC teaming. And the test that I want to show you is basically what happens if we have my client, which is this one. I just created some big files so we can have good time to make them copy and show you how this works. So let's do something. Let's start copying from client to physical and virtual and the other way around. I will just leave it like that. And we are going to test how the NIC teaming works here. Okay. Let's go here also, for example. Let's add this one. We can go the other way around. I'm going to, if you look at the path here, we can see it's the physical server. And here I'm going to my virtual machine. Okay, so let's put this one here so you can all see it. And let's go back. Okay, we can see here, right, that we have everything is copying. You see here, sorry, give me a second. Okay, perfect. We can see here in my performance counters that we have right now, there's a lot of activity, right, on both ways, because I'm just uploading, downloading from client, from virtual, from physical. So let's do the test here. We have everything working fine. And what happens, for example, in this case, I'm just forcing, but let's imagine this is that suddenly the network adapter fails. I'm going to disable this. You can see, if you look at here, we can see that everything's still working. The user didn't even notice there was a failure. And there we can see that it is appearing as faulted, not working. My team is showing just a warning, okay? This is not critical. It's just a warning saying, hey, we have some problem here. I can continue working, but you need to really take some action. Perfect. So here we see also in the performance counters, you could see before we had quite a lot of activity. Right now, if you see, we are missing 2 counters, right? Which is from the physical network adapter that I just disabled. Perfect. So let's go enable this one again. We still have our client. It's not even noticing that something happened. Let's wait until this one goes active. Okay, we already have it up and running again. Our NIC teaming shows us okay, no more warnings. So everything is working fine. If I just disable the second one, the same will happen. But basically, here we can see that even if one of the network adapters in the team fails, everything works fine. The user is not even noticing anything. You see, there is no stop here. There is no drop of the traffic. Everything continues working. So that's it, I think.
Yep. Go back to number 4.
4, right?
Now she's going to talk a little bit more about the costs.
Yes, so the second feature that I want to talk about, we had some improvements in Windows 2012, is cost, quality of services. Did anyone work with quality of services already? Yes? In Windows 2012 or directly in the, okay. So basically what we are going to have here is set control mechanism and technology used to manage traffic in an effective way and which ensures high quality performance. What we really mean with this is that we want to, in one side, prioritize traffic for applications that could be really important for us. So we really want to prioritize that traffic over the other. And also that we're going to handle and manage the bandwidth. Because we may have mission-critical applications that really we need them to be working all the time, but with a minimum bandwidth, for example. We cannot really afford having a mission-critical application that has a bandwidth that drops, right? We really need to ensure that we have a bottom line here. And the same for the other applications. We don't want other applications that are not that critical to take all the bandwidth available and make our mission-critical application drop even to the minimum. So basically, this is what we are going to achieve with QoS. And good thing is that we also have for both virtual networks and physical networks. So let's see each of the options. Policy-based QoS is for physical networks. What we have here, basically what we are going to do is we are going to configure these options through GPO. And if you go to the GPO, you're going to see that we have a wizard, and with 3-4 windows, each window will ask these things that we're going to see now. And the first one is the throttling rate. And here's what I told you. We can configure the minimum and maximum bandwidth that we want to apply to certain application, to certain traffic. One of the new features we have in here is that we can use DCB if the network adapter is capable of so. Data center bridging, if you remember I already talked about, is going to help also, and is going to bring minimum bandwidth assignment directly on the network adapter. So if we have DCB-capable network adapters, we can use them. We're going to have the traffic classification because we really need to say, OK, which traffic I want to give this different minimum and maximum, which one I want to prioritize. And how I'm going to do this is by using the 5-tuple again, IP address, source IP address, destination IP address, source and destination port, protocol type. So this is one of the options. We also, as we're using just GPO and we can apply to machines or users, we can just define this exactly for different users. And we can also just use the URI if we are using web services, a web server. So we can just say www.contelso.com/my-site. Specifically, that site is the one that I want to apply all this. And finally, how are we going to do this? We need to tag the packets that are flowing through the network adapters to understand how they need to prioritize that traffic, right? So we are going to use the SCP, which is tagging in the IP header. This was already present in previous versions of Windows, but the new thing we have here is that we can now use 802.1p tagging, which will be tagging directly in the Ethernet layer 2 for those ones which are non-IP packets like RDMA. If we're encrypting with AppSec, we can really already tag the packets and just give prioritization to them. And for Hyper-V QoS, we can just configure directly in the Hyper-V manager. We are going to have minimum and maximum bandwidth. The new thing here is that before we didn't have minimum bandwidth settings. And we're going to use the Hyper-V switch port again as identifier in this case for prioritizing and giving the enough bandwidth to the different packets. We can configure this through PowerShell and WMI. If you remember for physical, which was policy QoS, where with GPO here we can just easy management also by using PowerShell and WMI. And finally, we also have a very good news, which is that we can configure these different policies to the different virtual adapters. So we have a lot of granularity here that can give us much more flexibility when we want to configure different options for each virtual adapter. OK, so in this case, I think I'm done. Thank you.
So all these features that Karin just mentioned, the LBFO and the QoS, the LBFO can be used for resilience scenario in a private cloud. QoS can be for service metering and things like that. So you can use those capabilities. But what about security? What even care about network security in first place if everything is internal? So in theory, all my data center is full of people, internal people accessing my data center. So why do I even care about that? And here are some screenshots of some magazine and articles that really shows that people are really concerned about private cloud security. It's not because it's private that is secure by default. As a matter of fact, the main threat is still internal. So in a private cloud, it is not different. Your user is the main threat. He is already authenticated and authorized. So Intel, for example, did a survey on this diagram here that's asked what is the problem with private cloud, and the main one is access control. And as part of security, how can you manage the access control of your private cloud? If you lack on access control, someone might provision a service, or an application developer, for example, thinking that now he has something called infinite resources, he can allocate memory as much as he wants, right? Because it's infinite resource. He heard about elasticity, so now I can do whatever I want on this data center because all the resources are mine. So the internal threats are pretty much the main things to be concerned about. And some of the demonstrations that I will do here are going to address that. The first feature that we can leverage on Windows Server 2012 and 2012 R2 is the SMB encryption. It's probably one of the key features, in my opinion, on the network stack perspective. Because when you think about IP and we think about traffic security, we immediately think about IPsec. But what is the problem with IPsec? It requires a bunch of things. It requires certificates. It requires managing the certificate, a PKI infrastructure, and all that. Sometimes you really do not want to implement PKI for all the tenants. Some tenants might need something more simple. And one built-in capability on Windows Server 2012 is the SMB encryption that can enable encryption end-to-end on the SMB traffic itself. Now, keep in mind, IPsec is much better because it's the whole IP datagram. So no matter what protocol you are using it will be encrypted. But if you have only a file server that has some financial information and some data that you want to encrypt, why not use SMB encryption? Why not use this type of capability instead of implement IPsec? So it protects from eavesdropping attack. No need of a special hardware or IPsec, as I said. And the great thing about SMB encryption is that you can do per server or per share. So again, if you have a tenant on your network that has multiple shares, but there are some shares that he wants to encrypt because the information that's passing through the wire at that point is very important. He doesn't want to cause leakage when the data is in transit. Then you can implement this feature per share. Okay? And not only from the private cloud perspective, but you can also implement in a bunch of other scenarios. So let's go through the scenario description here and why we are going to do this demonstration. So the private cloud tenants read a report saying that internal threats are still the biggest concern in network security. The tenant has a file server on their segments that contains financial records and must be protected against eavesdropping launched from internal clients. Okay, so keep in mind that in a private cloud you have multiple tenants. The Hyper-V already leveraged some built-in functionalities for isolation between tenants. But what about the traffic within the tenant network? That's what we are trying to accomplish here, is to block and to encrypt the traffic within the network. So let's go through the demonstration. Mine is one.
Yeah.
So on this lab here, I have my Hyper-V with this 4 machine running. And I would just say that for this particular example, these 2 machines are inside the same tenant network. Okay, this is the file server and this is the client. So I'm going to create a simple file server, and the best way that I found to demonstrate this feature is really using Network Monitor, because you can really see what's going on the wire and why you cannot grab what is passing through the wire at that point. So I'm going to create a file share that is not encrypted. I'm going to use the quick wizard here, and I'm going to get this public folder that is on this server. I'll just leave the default configuration on, and on this last option I'm not going to use the encryption. So if you look at here, there's encryption. This is where I enable the SMB encryption, right? I'm not going to use that for this example because I really want clear text passing through, and I'm going to create this. Okay, create that. Go back here. Let's first access the folder. Okay, it's here. Now let's start Network Monitor real quick. Create a new capture. and start your capture. And let's go through the process of accessing the share, double click on the file. Okay, you should be able to read me here. Okay, I open the file, that's fine. And stop the capture. Okay, so here I have everything that is passing through. I can see my traffic. I can see my SMB traffic here, all the dialects to open to create. I could go over package by package so you can see, but it would be more optimized for our time to really go through and look at what is within the package. Okay, since network monitor allows me to search deep within the package for a keyword, let me see if I can find within the package something that says read. So if I apply this, I'm going to be able to find one particular package, which is the package that it shows when I was reading the file. So the file is here, okay? The file is exactly here. And if I start to look here to the information within the package, what I will find is that I was able to read the file, okay? This is what you want to avoid when you have SMB traffic on a network and you want to encrypt that traffic, because you want to avoid people to doing a simple netmon and capture that data. I'm going to leave that capture here, and I'm going to create a new capture, because now I'm going to create a new share and demonstrate the difference now with the folder called financial. Okay, on this financial folder, I'm going to encrypt the data, and it's just like that. I'm doing using UI just because I think it's much more fun for a demonstration purpose than running a script on PowerShell, but you could do everything via PowerShell. Okay, next, and create. Now I'm going to start to capture again and go through the financial. And on the financial, I have the file called confidential records, and I say NDA financial records. Okay, so in theory, right, assuming that this feature is working as it says it is working, if I do any filter for what data is within the SMB package, I should not be able to see the moments that I read that file. Okay. And I can go to the history here and say records. So I'm looking for this keyword records within the package. And apply is not there because it's encrypted. I say, well, how can I confirm that? What about if I filter for the IP of the server? So this server here, the IP is 30. So if I filter for the 30, I will see that I have a lot of traffic going through the server 30. And I will see the SMB dialect. So the SMB commands itself, I'm going to be able to see, create, query, all those commands. But when I go to the data itself, notice that is completely different. Okay? Now my data inside the package is encrypted. Okay? And I'm not able to read that data. So that's a simple setting that we have available on Server 2012 that can assist you in scenarios like that. Okay, pretty simple thing. As I said, you can automate that using PowerShell. You can enable or disable using PowerShell as well. It's 6, right?
Yeah. No, 6 is mine.
No, it's 4.
Yeah. The red one.
Okay. So that was one scenario. What about rogue servers? One of the main problems that we had in the past, and we still have this problem, is about, well, someone instantiate a rogue server on my network. Okay? What happens if you instantiate a Linux DHCP server on network and start to distribute rogue IP addresses? People will start to grab those IP addresses. And the most common scenario is not that they will give you a rogue IP. From the attacker perspective, what they really want to do is that they want to do things without you even notice that there's something wrong. So ideally, everything's going to continue work on your network, and you will not even notice. But what happened behind the scene was, a malicious user instantiates a Linux box with a DHCP. Okay? It also instantiates a proxy server. And now you have a DHCP and a proxy. So DHCP will provide a valid IP address, but the wrong default gateway. Okay? So at that point on, my clients are receiving IP with this new default gateway, and I send information to this ROG proxy server. God knows what it's trying to do. The only thing that I know is that it's grabbing all that information and doing something with it. Okay? That's the most common scenario, is doing things, avoiding you to know that something is wrong. In the past, the idea was, oh, I'm going to do a DOS. I want to put these people down. Okay, I'm going to just give a ROG IP address. No one can access anything. The mentality now is different. The mentality is, well, I want to do an attack, and people do not even perceive that something is wrong is going on in the network. So the ROG DHCP server is really a common example of instantiate things, so that point on you can start all the different attack vectors because you already own the IP address of the clients. And with Hyper-V switch, you have a very interesting feature called DHCP guard. With the DHCP guard feature, what you do is you're going to implement on the switch level a protection that will block DHCP from offer IP address. This has nothing to do with DHCP authorization, AD, DHCP, nothing. And that's the beauty of this thing, is because it works on the switch level. Okay, it's implemented on the switch level, so it doesn't really matter if your ROG DHCP is a Windows or a Linux box. Okay, it will work the same way. So to demonstrate that, the scenario is the private cloud tenant read the paper, Solutions for Private Cloud Security from Microsoft, and wants to ensure that his network segment is protected against ROG servers, clients and application. This paper we wrote on our team has a lot of scenarios. We don't go over how to implement those scenarios, but it at least gives you an idea what are the potential scenarios for attack. So let's go back here to number 1. So for this scenario, I'm going to use a different server. Not going to use this box here anymore. I'm going to still using this one because this is my DHCP server. Here's the scope. Here's a valid scope. And just to make it easier and faster for me to do some demonstrations, I'm going to use a Windows Server 23 client. And my ROG DHCP also will be a Server 23. Because it doesn't really matter who is going to be there. It could be a Linux. It's just because I want to allocate 512 meg of memory, and it's much easier with 2003. So this client, I'm going to call victim, is leasing IP from my valid DHCP server, which is the DHCP 3030. Okay, so I can see here that's my DHCP is valid. When it will be the attack vector here? Usually the attack vector will be when I try to renew the IP. If I have on my network a ROG IP server at that point, and if for some reason I cannot contact my original DHCP server, that ROG DHCP server might interfere and say, hey, I have IP here. You were not able to talk with that guy. I can offer to you. So to force that, what I will do is I'm going to instantiate this DHCP, which right now is stopped. Okay. I'm just going to start this guy, and I'm going to shut down this one. Deactivate. Notice, I'm just forcing this scenario, otherwise you're going to be here the whole day trying to simulate this timing thing. So I just need to force this configuration to happen. So I'm going to release. Okay, and when I renew, I should renew for the ROG server. Okay. Even for renew, sometimes it takes a while because it's going to try to contact the original one, and since it's not online, let's take a look here. Already renew. Okay, now even got a ROG DHCP. get here the IP address of the DHCP. Okay, it's 3035. Okay, so I was able to get that information. Fine. Now let me start network monitor on this box, because again, the impact you only see if you look through the wire. Otherwise, it's just one checkbox on the Hyper-V switch. It's not even fun. So let's open network monitor in both places. And the reason I'm opening network monitor in both servers is because you really need to see that things are happening in the lower level. It's not on the application layer. Okay? So let me start a capture right here and a capture right here. What I will do to block this server to offer IP address is a simple configuration on the properties of this VM itself, okay, which is called DHCP guard. That's it. That's the only thing that I need to do, okay? Now, the question that you probably could ask at this point is, hey, so do I need to enable this feature in all my VMs that I want to block? Well, let's think the other way. When you start provisioning new VMs, this option should be enabled by default. The exception is disable when you want a DHCP server. Okay? So when you are building a template of VMs to distribute and to instantiate, this option should be there by default, because unless someone asks to be a DHCP server, it shouldn't be. Right? So that's just a matter of using PowerShell to automate this process. When you instantiate, this option is already enabled. Okay? So because if you look to this perspective, oh, do I need to go in all VMs and enable this? Yes. But if you think the other way around, it will be much easier. Okay? So now that I have this feature enabled, let's start the traffic, the capture in both ways. And let me release the IP again. Okay, release. And now let me renew. Now, what is going to be interesting here is that you're going to see this guy sending requests. Okay, you're going to see this server, the client sending requests. You see request, request, and the other one is sending reply. And he continues sending requests. Okay, so we have requests in one side and reply on the other. Okay, you can see here reply. Okay, but I'm continuing to send requests. Look again, I continue to send reply. Now, why this is happening? Why I'm sending requests, here sending reply, and we never agree on something? Because in between the client and the server, you have what? The Hyper-V virtual switch. And on the switch level, I say that box, that VM, is not a DHCP server. Do not allow DHCP packets to go anywhere. Okay, that's why I keep sending offer, and since he does not listen to those offers, he keeps sending requests. So this level of protection is out of the box on the switch level. This is much more secure than you say, well, I have to authorize on my AD. No, because now you are on the switch level. It does not even need to go to the application level, okay? And at some point, it will time out, just like it did, okay, right now. And if I look here, I probably got 169 IP. Okay, if I stop the capture here, you're going to see a lot of requests, and reply. In other words, this box does receive the request. So the Hyper-V switch is intelligent enough to say, hey, this guy is sending requests. Let me reply with a DHCP offer, and replies. But the offer never gets to the other side. Is that clear? So again, this is implemented on the Hyper-V virtual switch. It's a pretty cool feature. Because of that box that I enabled. Remember? Right here. So on this, when I enable this DHCP guard right here, what I'm pretty much saying is this machine is not allowed to offer IP to anyone. So this machine is not authorized at all. Cannot offer to anyone. Okay? So in other words, my DHCP server should have this option clear. Otherwise, it will not be able to work. So this is a level of protection on my DHCP that on my Hyper-V switch. There are other things on the Hyper-V switch that are pretty cool as well, such as port echo. And those features, you do have the capability to implement on a piece of hardware switch. But what Hyper-V is doing is bring all those capabilities to the virtual world. Okay? So with port echo, you could create rules to say, hey, this VM cannot talk with that other particular VM. Because the DHCP guard is one to all. Once you enable that option, I cannot offer DHCP for anyone. Okay? The port echo, it allows you to create rules like a firewall. But that you do on the hypervisor, and that you can only do via PowerShell. You cannot do via UI. Okay? But that is a very flexible type of thing, because you pretty much build a table saying what you want to allow and what you do not want to allow. Okay? And then comes the question, what about some intelligence behind this? What about if I'm receiving an attack, like a port scan? Port scan is a very well-known attack, has a pattern. So if I'm receiving an attack like a port scan, can the Hyper-V switch block that intelligently because it knows it's an attack? Well, Microsoft, we do not do that out of the box, but we have one thing called Hyper-V extensible switch that allows third parties to develop solutions to do that. So there are solutions from Cisco and other vendors that allows you to have a piece of firewall within the Hyper-V switch. Then what we'll do is it will create port echoes as a traffic seems to be malicious or not. That's another feature that we have built in on Hyper-V. Again, some people are comparing this with vShield from VMware, but vShield does that without needing a third party. What we did was we said, well, there are so many things to explore in this area. You could do malware inspection, for example, on the Hyper-V switch level. So why not leave this option open for third-party vendors to develop other solutions to hook in our Hyper-V switch? So we left this open for vendors. Another feature that we have also on the Hyper-V switch is called MAC address spoofing. MAC address spoof is a very common type of attack. I will spoof a MAC address. I will change that MAC address to mess up with the ARP table of my VMs and to receive traffic pretending to be someone that I'm not. Okay, so with the Hyper-V MAC address spoofing capability, I can pretty much mitigate this type of attack. And again, there's only one checkbox on the UI or via PowerShell as well. So a lot of features built in on the platform. And moving forward, we do have some enhancements on R2 that Carmen will talk a little bit more about it.
Yeah. We're talking about a little bit just of a few new enhancements that we have in R2. One is extended ACLs. Yuri already said what ACLs are here. And if you have seen, we can just configure to allow or block traffic based on virtual machines, right? So with extended ACLs, we have now more flexibility, more granularity, because we are going to use network ID, we are going to use source and destination IP address, we can use source and destination port, we can use protocol. And another new good thing that we are adding in extended ACLs is that we are doing stateful inspection. What is stateful inspection? Basically, we are going to check what is the state of this connection. Is this open? Is this already closed? Whatever. And based on that, we are going to allow ordinary traffic. Because, for example, if our connection is already closed and we still receive packets, we really may think, hey, what is this packet coming from? Why? It shouldn't be here, right? So this is one of the things that we're going to do. We also have virtual RSS, just like we have RSS in physical network adapters, just spreading the processing of the traffic through the different adapters. We are going to do exactly the same with the virtual adapters in the virtual world. We have virtual RSS. We are going to spread the processing of the traffic along the different adapters, virtual adapters. And finally, we already talked about NIC teaming. We had address hashing. We had Hyper-V switchport as algorithms for load balancing the traffic. We have now NIC teaming dynamic mode, which is a new mode here. What we're going to use for outbound traffic is we are going to split the traffic. We are going to split the workflow, basically, in different chunks. Some natural gaps that we can find in the traffic, for example, different packets that we have, which are just acknowledged with an ACK. We are going to take those chunks and are the ones that we are going to start spreading all over the adapters. So these are just some of them. I really encourage you to go through the presentation we had this morning, which was really very interesting about all the R2 new enhancement that we have about networking.
Yeah, this is the session, MDC B216. It's a 200-level session, but it gives a very good idea of what's new on this area. So you should take a look. It was this morning, but it is recorded, so you can watch later. So in conclusion, architecting network infrastructure is an essential step to a modern data center. As you go through the whole strategy and the whole planning thing, it's important that you know that network, compute, and storage is a world of infinite things to configure and to predict, and always take into consideration security for each one of those capabilities. Planning and design, I work with cloud principles, so even if you are not moving to the cloud, as we said before, try to bake in some cloud capabilities on your data center, because sooner or later you are going to see a lot of value using those capabilities. And leverage built-in capabilities on Server 2012 R2 for your network infrastructure. Here is, we try to go through some details in some of the features that are very essentials. Take a look on that presentation about enhancements on R2. There are a lot of things, although R2 is not a full new release, but there are a lot of things that were done since last year to this year on that area. Some of the sessions that we truly recommend you to take a look are here to complete the whole story about planning the cloud and moving to a cloud infrastructure. You can get this slide later. And last but not least, please evaluate the session. Give us some feedbacks, what you want to see. We delivered this session as 300 because the feedback that we received before, it was when we set the session as 200, people were like, no, there are too many things. This should be a 300 level. So we changed for 300. If you think it's 200, put 200 again, but give us your feedback. As you know, you can just put your phone to this tag and evaluate. If you have any question on the session, please let me know. Let us know now. If not, you can contact us, yurid@microsoft.com.
Karen Shibi
at Microsoft.com. Okay, so thanks a lot for your time today. It's 6 minutes that I'm going to give away for you to get ready for the party and enjoy the rest of TechEd. I appreciate it. Thank you.